Have you ever wondered how programming languages evolved from cryptic machine instructions to simple, readable code like Python? In this video, we'll take a quick and easy journey through time from the earliest computer languages to modern programming languages and understand why each new language was created. Let's rewind to where it all began. The first computers were programmed using machine language, just zeros and ones. Programmers literally had to write long sequences of binary numbers to make the computer do anything. As you can imagine, this was extremely difficult, very error prone, and almost impossible to debug. So naturally, programmers wanted something that was easier for humans to read and write. That's where assembly language came in during the 1950s. Instead of writing raw binary, programmers could now use simple instructions like ADD, MOV, or SUBI. This was a big improvement because the code finally looked somewhat readable. But assembly was still very close to hardware, meaning programs were tied to specific machines. So, while it was better than machine language, it still wasn't ideal for building large or complex software. Fortran was built for scientific calculations and was the first high level language. Next came the first high level programming languages. In 1957, Fortran was introduced mainly for scientific and mathematical calculations. Shortly after, COBOL appeared, designed for business and financial systems. These languages allowed programmers to write code using English like statements without worrying too much about the underlying hardware. This made programming faster, easier, and more accessible. But the code was still often bulky and hard to maintain. Then came one of the most influential languages ever created, C, developed in 1972. C struck a perfect balance. It was powerful and fast, yet still flexible and portable across different systems. For the first time, developers could write structured programs that worked close to the hardware but were still relatively easy to understand. C became the foundation for operating systems like Unix, and many modern languages are built on top of it. However, C had one major downside: manual memory management, which could easily lead to bugs. To solve that, C++ was introduced in the 1980s. C++ added object oriented programming, which allowed developers to organize code using classes and objects. This made large software systems easier to manage, reuse, and scale. But the language also became more complex, especially for beginners. So, while C++ was powerful, it wasn't exactly beginner friendly. In the 90s, the internet changed everything. Java was introduced with the idea of write once, run anywhere. It handled memory automatically and worked across platforms, making applications more secure and portable. At the same time, JavaScript emerged to make websites interactive. It allowed web pages to respond to user actions and eventually became one of the most important languages in the world. Then came Python, originally released in 91, but it became massively popular in the 2000s. Python focused on simplicity and readability. Instead of complex syntax, Python lets you write code that almost looks like plain English. This made it incredibly popular for beginners, data science, AI, machine learning, automation, and web development. Python removed much of the complexity found in earlier languages while still being extremely powerful. In recent years, we've seen modern languages like Go, designed for speed and cloud systems; Rust, focused on memory, safety, and performance; Kotlin, a safer and cleaner alternative to Java, Swift, built for modern Apple app development. These languages focus on developer productivity, performance, and safety, learning from decades of past mistakes. So, when you look at the evolution of programming languages, you'll notice one pattern. Every new language was created to fix the problems of the previous ones, making programming safer, faster, and easier. From binary code to Python simplicity, the journey has been incredible. And the big question is, what do you think the next programming language will focus on? AI, natural language, or something entirely new?